Jai Hind everyone, I am Vaishali Rastogi, Assistant Professor at Department of Computer Science and Engineering at Ajay Kumar Garg Engineering College. Today we are having topic instruction format and its type. Under this topic comes under in computer organization and architecture. So let's start with the topic. First, we are going to understand what is instruction. Before going with the format and types, we should know the proper definition of instruction. What instruction says. Basically, a computer instruction is an order to given to a computer processor by a computer program. Basically, whenever we are just talking about an instruction, it is nothing but a order given to a computer processor by computer program. Whenever we are going to execute any program, it is always a combination of so many instructions, and it should be in an order format. Basically, we are going to learn about the instruction and format. So here we have to understand instruction in a depth level. At the lowest level, each instruction is a sequence of 0 and 1. If we are talking about the deepest level, it should be a combination of 0 and 1 that describe physical operation the computer is to perform. Whatever operation computer wants to perform, it always combines the instruction format like 0 1 0 1 1 and so on. So this is the basic introduction of instruction. Again, and further we are just discussing computer instruction. Basically have three fields. It have three fields. These include an operation code or opcode. We also call opcode as operation code field that identifies the operation to be performed, such as add data into the memory to a specific register. They also have an address field showing where register and memory are located. Means it has two main locations, which is first is opcode and another one is address field. These are the main place which an instruction contains. An address field is showing where the register and the memory is located of the instruction, and a mode field. Third part is mode field showing how the registers and memory will perform. Mode field shows that how the register and memory will perform a task. Okay, so this was the basic introduction of any instruction. Let's continue. How do computer instruction work? Because we are going to understand about the format and types, we should know that how this computer instruction is working inside the computer. So computer programs provide the instruction that the computer system needs using a keyboard or other type of input devices. We have so many input devices. Whenever we want to give instruction to our computer, we have to use any input device and just we provide the instruction to computer. The computer's operating system, OS, or other software applications are programmed to interpret and execute these instructions. Whatever instruction we are giving using input devices, the computer has this ability to using this operating system, they can interpret and execute those instructions. Depending on particular instruction type, instructions specify special storage area called register that may contain data to be used in carrying out an instruction. Okay, so in last, instructions also specify the location in computer memory of the data and the input output format to be used. So this is the basic concept of working of computer instruction. It includes starting from the input devices, execution, processing, and the complete input output format following the output as our requirement. Okay, so let's continue further. Next, we are going to study about the components of a computer instruction. What are the components? Components is basically like if I'm saying this field occupy a instruction. So what fields should be there to complete a instruction? First one is opcode, address field, and mode field. As I told you in our previous slides. So the first partition is nothing but the opcode. What opcode says that this field describes the operation that is to be performed. Okay, nothing, we are just going to describe the operation, whatever the instruction is going to perform. And the second field is address field. What address field says? This field indicates where register or memory addresses are located, the address of the instruction. These are the referred as to the operands or the data that will be operated on the manipulated instruction. So here in address field we are just going to see the where the instruction is going to locate. Okay, and the third part is our mode field. What is mode field? This field specifies how the operand will perform. What is the operation and how it is going to perform? It comes under the mode field. So these three fields are the main components of a computer instruction. Because next we are going to understand about the format. We first know the basic concept, basic component of an instruction. So now we know the what is instruction, how the instruction works, and here we also studied the components of computer instruction. So let's start with the basic and main important terminology, which is nothing opcode and operand. These are the main play part of the instruction. What is operand? Here in diagram you can see a basic instruction is given. So instruction is move A, B 78. So how we will specify? These have two parts. First one is opcode and another one is operand. Opcode is a part of instruction that tells the processor what should be done, and operand is a part of the instruction that contains the data to be acted on or the memory location of the data in the register. Okay, so this is the mnemonic and this is the operand and this is the opcode, and I have already told you about the definition of opcode and operand. So a small instruction, dummy instruction you can say, looks like this. Okay, so next we are going to learn about basic computer instruction format. So here in the screen you can see that there are three types of instruction format. First one is memory reference instruction, another one is register reference instruction, and third one is input output instruction. These three formats are the basic formats of a computer instruction. So how it contains this, in three you can see that one thing is common. All three are of 16-bit instruction, 0 to 15. All three are the 16-bit instruction, and the three instruction defines three types of instruction format. So let's discuss the first one. First one you can see in diagram, there is a partition of 0 to 11th bit, 12 to 14 bit, and another last one is 15 bit. Here you can see 0 to 11, again 12 to 15th bit, and here up to we can say this can be up to 14 bit. Again here in input output, here you can see 0 to 11th bit is the IO operation part, and 12 to 14 is a opcode, and 15th is the highest bit. What are these bits? We should know the basic and detailed theory about these partitions. So in short you can say opcode determines 3 digits. Okay, 12 to 14 means the combination of 3 basic digits can be 000 to 110, and here in opcode field we can have 111 only, and the last bit is always 0, this one in register reference instruction. And again in input output instruction the opcode will be 111 and the higher bit always be 1. Okay, so these are the basic difference between memory reference instruction, register reference instruction, and input output instruction. Let's discuss these three basic instruction in a depth. So the basic computer has 3 instruction code format, and it all has 16 bit. The operation code, basically we can call it as a opcode. The operation code part of the instruction contains 3 bits, and the meaning of the remaining 13 bits depends on the operation code encountered. A memory instruction uses 12 bits to specify an address and 1 bit to specify the addressing mode. And in register reference instruction, basically here we recognize by the operation code, which is opcode. This should be 111, as we have seen here, this 111. Okay, with last bit is 0, which is the leftmost bit, bit 15. It should be always 0. Again, a register reference instruction, an operation on a trace of data, that is basically AC register. An operand from memory is not needed. Therefore, the other 12 bits are used to specify the operation or test to be executed. And last, similarly, we are having our input output instruction. Basically, here we have instruction does not need a reference to memory, and it recognized by the operation code, which is 111, and the last one is always 1. Last bit will always be 1. In the leftmost bit of the instruction, the remaining 12 bits are used to specify the type of input output operation or test performed. These are the 12 remaining bits. This will specify the type of input output operation or test performed. So here we have understood the basic computer instruction format in depth. Now we are having addressing of instruction. What is addressing of instruction? Addressing of instruction is basically every instruction of a program has to operate on data. Okay, so the method of specifying the data to be operated by instruction is called addressing. This is the main definition of addressing of instruction. The method of specifying the data to be operated by instruction is called addressing. Now let's move forward. We are having types of address instruction. So based on number of addresses, instructions are classified as 3 address instruction, 2 address instruction, 1 address instruction, and 0 address instruction. We can also make a good flowchart of this to score good marks, like types of instruction. First one is 3 address instruction. Another one is 2 address instruction, 1 address instruction, and the last one is 0 address instruction. If you want to score good marks, you just need to create this kind of flow chart, and if you describe in this way, you will have good marks in exams. Okay, so let's discuss all these types of address instruction in depth one by one. First, we are going to study about the 3 address instruction. What is 3 address instruction? Here we have at least 3 address locations. Okay, so computer with 3 address instructions format can use each address fields to specify either a processor register or a memory operand. Here in this example, we also describe and evaluating this expression using 3 address instruction. So first, you must be clear with that in this format we are having at least 3 location at a time. Okay, so what if we are having this example, x is equal to a plus b, multiply by C plus D. So what we are going to do? We are going to just implement and evaluate this expression using 3 address instruction. So first what we need to do? We just going to solve this A plus B part. Here we have any memory location which is name of A and another location which is M of B, means B part this, and we have to add this and move towards the another location which we have taken as a R1. So what would be the assembly code? Which is add R1 A comma B. So this would be the first step to solve this expression. And again we have another part. According to board mass, we have to solve this C plus D part. So again we are going to allocate to take a location for C, which is M of C, and one location for D, which is M of D. Okay, and we have to apply addition operation among them. So we have applied this addition operator between C and D memory location. And what we are going to do? We are just going to add and put the result into the R2 register. Okay, now how we will write an assembly code, which is add R2 C comma D. It means that add the content of C and D and move into the R2. And the last step, we have evaluated this part and this part. So now we have to take this asterisk part. So we have this data in R1 and this data in R2. Now we are going to just multiply among R1 and R2. So here multiply R1 and R2 content and move the data or the result into the M of X. X is a memory location. You can also call it as a temporary memory location. So here multiply between R1 and R2 and move the content and the result of R1 and R2 into the X. So I think you have understand the basic 3 steps of solving this expression using 3 address instruction. In detail, if we understand this example, basically we are going to assume that the computer has 2 processors, R1 and R2. The symbol MA denotes the operand at memory address symbolized by A. We are going to we are talking about this MA. The advantage of 3 address format is that it is the result. It results in short programs when the evaluating arithmetic expression. Okay, whenever we have any expression, 3 address format basically result in a short program. And again we are also having a disadvantage. What is that? Disadvantage is that the binary coded instruction required too many bits to specify 3 addresses. We need so many bits to express this 3 address instruction. An example of commercial computer that uses 3 address instruction is Cyber 170. The instruction format in the cyber computer are restricted to either 3 register address fields or 2 register address field and 1 memory address field. Okay, I hope you have understood the 3 address instruction in detail. So next we have completed this. Now we are going towards the 2 address instruction. Let's study. Okay, in 2 address instruction, there are most common. These are very most common in commercial computers. Here again, each address field can specify either a processor register or a memory word. Again we have same example and we have to solve this example or evaluate this expression using 2 address instruction. Here we have only 2 memory location. First one we can have as a processor register or another one is a memory word. Let's solve it. So in first step we are just going to resolve this A plus B part. So we have taken MA of memory location of A and we are going to move this content into the R1, which is showing move R1 comma A. And again we are having R1 plus M comma B. M comma B is nothing but the location, memory location of B. And we are going to merge the content of A, which is in which is in R1, we are going to merge the R1 plus the memory location of B data, and we are going to put the result into the R1. Okay, it is something like we are having R1 location, we have put A into R1, the content of A into R1, and again we are having any memory location which is M of B. So we are going to just merge the content of R1 with the memory location data of B, and after getting the result we are going to put all the result into the R1. Means now R1 includes A plus B. Okay, so R1 is having the resultant of A plus B. Again we are going to understand about the C plus D part. So we will apply the same approach, which is M of C, memory location of C. We will move the data of M of C, C location, into R2 register. We have taken another register which is name of R2, and we are going to put the data into R2 register. So this operation basically move R2 comma C, and in next step we are going to just add the content of memory location D with the register R2. Add the content of memory location D into R2 register and put the summation or the result into R2 register. Okay, so how we write it? Add R2 comma D. Now we have R1 as A plus B and R2 is C plus D. So what we are going to do? We are going to just multiply R1 with R2, the content of R1 with the content of R2, and again we don't want too many locations. So what we are going to do? We just put all the output of this resultant into R1. So here multiplication of R1 into R2 and put the result into the R1. This is MUL R1 comma R2. So in R1 we are having the complete answer of A plus B multiplied by C plus D, and we have to take into the memory location. So what we are going to take as a MX. MX is a temporary memory location, and we are just moving the data of R1 into memory location X. So this was the basic and full content of to address instruction with a good example. In detail, if we are going to discuss about this, so the move instruction moves or transfer the operand to end from memory and processor register. What this move is doing? It is just moving the data or transferring the data of a location into a register. Okay, the first symbol listed in an instruction is assumed to be both a source and a destination. This is the main part of this address instruction, that the first part, whatever, like in this step we can say the R1 is also involved in the calculation. Again the resultant is going to store within the self. So this is the main concept in to address instruction. Again here we were the destination where the result of the operation is transferred. This is the main key point of to address instruction. Let's continue with the next. We are having one address instruction. Okay, we have understood 3, 2. Now we are having one address instruction. So let's see here. One address instruction uses an implied accumulator. This is the USP in one address instruction, because here we are limited with the memory location. So we need something, because if we are going to calculate or evaluate any expression, it is always among or between more than one sources. So we required at least more than one location, and here we cannot use more than one location, memory location. So how we are going to evaluate? Here we take the help from accumulator. This plays a very great and huge role in one address instruction. This is nothing but a simple register for all data manipulation. We use it for data manipulation. For multiplication and division, there is a need of a second register. However, here we neglect the second and assume that the accumulator contains the result of all operations. The program to evaluate this. Now we have to write the program for this, and again we are having the same expression, which is x is equal to a plus b multiplied by c plus d. How we are going to solve it? We have so many steps here, you can see. So here one restriction is there, we can use only one memory location on a single time, and for calculation purpose we required another place to put our data. We are having this accumulator register. Okay, so accumulator, first step is saying move the content or transfer or load the content of memory location A into the accumulator, which is load A. Okay, this. And in next step we can write as a what we are going to do, we are just going to add sorry, this is not A of C, this is basically normal AC. We are going to just, this is A and C, we are just going to add this is now in AC with memory location of B. Okay, and we will put the content resultant into AC. It means that add AC with MB and put the content into AC, which is add B. In short, we can write it as a add B. In next step, now we the accumulator is having A plus B, and again it has to calculate some data. So how it is going to perform? It has to be free. So this will move its content into the T memory location. This is something a temporary memory location, and we can write it as a store T, means store the content of accumulator into the memory location T. So we have solved this part. Again we are having C plus D. So we will repeat the same steps as we have done with the A plus B. We will move or load the content of memory location C into AC, which we can write as a load C. And in next step we have to now AC indicates the location content of C, and we have to add this with content of MD, and we have to put the resultant into AC. So this is something, add D with the content of AC and put the data into the AC. So AC right now having C plus D and some location memory location of T is having A plus B. Now what we are going to do? We are just going to multiply the content of MT with the content of accumulator and putting the final resultant into accumulator. Okay, so here accumulator ki content of accumulator will be multiplied with memory location T, and the resultant will be transferred to AC. We can write it as a MULT, multi. Okay, so now in last, AC is holding the final summation of this. Okay, AC is indicating the final expression, but AC cannot store data for a long time. We have to transfer the data into a memory location. So we have choose again a memory location X. We will put all the data of AC into the memory location X, which is store X. I hope you are clear with this one address instruction. So in detail, what we have learned, all operations are done between accumulator register and memory operand. T is the address of temporary memory location required for storing the intermediate results. This was the one address instruction. Next we are going to learn about the final type, which is zero address instruction. Okay, So in next slide you are going to learn about the zero address instruction. सर यहाँ से कट लेना है, ठीक है, यहाँ से कट लेना, मैं स्किप कर रही हूँ बीच का पार्ट, फाइनल पे जा रही हूँ, यहाँ जहाँ मैं बोल रही हूँ ना यहाँ से कट ले लेना, ठीक है, क्योंकि यहाँ से फिर बीच का स्लाइड में मिस कर रही हूँ. So here we are going to learn about zero address instruction. What is zero address instruction? A stack organized computer does not use an address field for the instruction which is add and mul. The push and pop instruction, however, needed an address field to specify the operand communicates with the stack. The following program shows how x a plus b and multiplied by c plus d will be written for stack organization computer. Here we have one keyword. We are going to solve again this a plus b into c plus d with the help of zero address register. One keyword we have to take care of, the TOS, top of stack, and we are going to use stack over here because we cannot use any memory location inside the zero address instruction. So stack will be helpful in our this address instruction. So let's solve. The expression was x is equal to a plus b multiplied by c plus d. Okay, so this is the complete solution for this expression. First we are going to take a stack. We will just push and pop the data of the expression, and we will just resolve the content of expressions of this x equation. Okay, for here we just going to evaluate the arithmetic expression in stack computer. It is necessary to convert the expression into reverse Polish notation. First we have to convert this into reverse Polish notation. What reverse Polish is? Like a plus b will become a b plus. Okay, and the name zero address register is given to this type of computer because of the absence of address field in the computation instruction. We are having no memory location for this, hence we are going to use only stack for this. So let's start. First what we are going to do, this is top of stack which is indicating this right now. We will just put or push a, content of a would be here, again TOS will be there, push b, basically b, and again add. We are going to put the add operation. So what will happen, the last top two element will be applying this operation which is add. So final TOS indicate as a plus b, and again we are already solved a plus b part. Now we are going to solve this c plus d part with the same approach. So now top of stack will indicate c, which is nothing but the push c, and then top of stack will have d, which is having push d. Now stack top is showing the content of d as a top of stack, and we have to again do the addition operation. So the top of stack now indicates as a c plus d, the resultant of c plus d. What now we have to do? We are having already a plus b, and now we have resolved c plus d part. We have to multiply these all both content and put the final solution as a top of stack. So a c plus d multiply by a plus b and put the resultant into top of stack with the help of mul instruction. Now the final resultant holds TOS. So put the data or pop the final resultant from the stack, which is put the top of stack content into mx location, which is a normal temporary location, and for taking the final output we are applying the pop operation. So here we have used the two operations, which is push and pop, and we applied all the approach for multiplication and addition, and hence we have solved this equation with zero address instruction. So here in this topic we have covered instruction and its types, formats, and complete process of working instruction. Okay, so these are some references, and thank you for this.